Mm-hmm.
There you go.
What's up, brothers?
Happy Canada Day.
Canada, hey!
That's right.
Huey Lewis, that's they're Canadian. I didn't know that.
I don't know. Is Huey Lewis Canadian? I didn't think he was.
I don't know.
Neil Young is Canadian. Anne Murray,
Alanis Morissette.
Burton Cummings, the Bare Naked Ladies, Randy Bachman.
But
Rush.
wasn't the song in Back to the Future with?
It was. Yes.
That's the connection.
There's the connection. Yes. It was in Back to the Future. The Power of Love. And I got to go back in time and all that other good stuff. Hey, how are you doing, people? Welcome back to yet another edition of Takeo After Dark. Summer School.
Tad
Tad.
for sure.
Yeah, Tad Summer School. And we are a tad early in our start or a tad late. I'm not sure which. Well, good evening, everybody. John Barba. Let's do a quick roll call. John Barba here. Rick Mayo.
Rick Mayo.
Dave Holdorf here.
Dave Holdorf.
Rick Mayo. Here.
And
John. Uh-oh.
we've got John and Tim. Say
Oh,
hi,
yeah.
boys.
Hello,
Tim here.
everybody.
Oh, yeah, you guys. Right. We have John Messenbrink and Tim Ward from Mechanical Hub here with us as well. And we're getting ready for yet another edition, our second edition of Takeo After Dark Summer School. And if you were with us last week, you know, we started doing a whole house heat loss. And then we did some crowdsourcing for the topic that that you guys wanted to learn about this week. Well, we're going to do part two of the heat loss. First 20 minutes or so, we're going to talk about that heat loss and go over the rest of the project, see what you guys come up with, etc. And then we were going to go into water treatment, all right, because that was the crowdsourced program that you guys wanted, that you guys voted for last week. Unfortunately, our water treatment guy chose this week of all weeks, go figure, to go on vacation. So he's up at a lake somewhere in northern Minnesota, and we don't know where he is
He's
or
been
what
on
he's up
vacation
to.
for like 4 months now, hasn't he? Everybody's been on vacation for 4 months now.
Well, not Patrick. Patrick's one of those conscientious type dudes. He does not. He does. If it's a work day, it's a work day. He'll put it. You pay him for 8, he'll give you 10 to 12. He's just that kind of guy. But next Wednesday we'll have Patrick S., a salesman for the Mondale Company out of Minneapolis, to talk to us about boiler water treatment. Our substitute class for this week is going to be a topic we started discussing last week after the program that we really got into, and it's something that between Rick, Dave, and I, we have a pretty good grasp on, and that is radiant floor heating. You got 3 guys in one room that know an awful lot about radiant floor heating and radiant design, and Dave will walk us through some radiant design in the second portion of the show. And please make sure you guys ask a lot of questions on that, because we'll have some fun with it. One of the things we wanted to do in advance of this second part, and again, this is Takeo After Dark episode 2, and we're going to finish up the heat loss. And there's our man Bruce Campbell. All right, it's not like we, he's, remember, during the original Takeo After Dark, he was in a smoking jacket and a chair. Hey, it's summer school. He's shirtless in a hot tub because that's where we should all be. Anyway, hey, there's an idea. Who's got a hot tub? Rick, do you have a hot tub?
No.
Dave, you have a hot tub?
No.
You got a pool. You got a pool.
I got a pool.
You got a pool and a pond. A pond would be good for you.
Looks like the type of guy that would.
Yeah. Do you get Wi-Fi at your pool?
I do, yes.
Dude, my landlady has a hot tub. I'm thinking next week.
Well, tonight we just had a major hail and lightning and everything came through here about 5 minutes ago. I wasn't sure if I was going to make it tonight.
Oh,
so
gosh,
thought
that would have been
power
fun.
Yeah, I thought the power was going down any minute now. So, and it
Oh,
passed
boy.
already. So it was pretty nasty for a while. So, but I did think about the pool. Yes.
I think that I like that idea.
I only just got it hooked up last week too, so that's why I was thinking about it.
Well, tonight's theme, as you may have guessed from the T-shirt, Biff Tannen's Pleasure Paradise, is Back to the Future. So we're going to get started. Last week we gave you guys a worksheet, a whole package to do a heat loss for a house, and we did a poll. We gave you guys a set of blueprints for Norwich, Connecticut, this big house, and we asked you guys to take a wild guess, or even an educated wild guess, on the heat load of the house. And Dave, what were those options? I think we're like 51,000 was the lowest, up to 100 and something.
Oh, damn it. It did have it here. Hang on a second. It's buried in here.
No, well, that's all right. It was something along those lines anyway. And we voted on it, and most of you guys were kind of on the low, I think in the 70,000 range for a guess. Now that you've had the chance to do this, for those of you who did do it, we do have I'm going to give you the next 5 minutes to type in your answer. What we're going to do is we have a special gift package that Dave put together to anybody who comes the closest. All right, and if we got a bunch of people who are pretty close, we're going to do the
Nice.
we're going to do a random drawing. And what do we have? Oh gosh, what do we have there, Dave? Look at that.
I got a nice Carhartt backpack here.
All right. Very good.
Yes.
Oh, very nice. Nice Carhartt Takeo backpack. Excellent.
Yep.
So what we'd like you to do is type in your question section your best estimate, what you came up with for a heat load, and then we'll take all the correct answers, put them in a hopper, and pick the best one, or pick the right one.
If there's only
Pick
one,
one
then
at
it's one
random. That's what we're saying. There we go. Pick one at random. All righty, very good. So yeah, just put in your best your estimates there. Oh, a bunch of them are coming in. Excellent. Very good. Very good. Very good. So that's terrific.
Whole house. Whole
Yep,
house.
the whole house heat loss. The whole house heat loss. Very good. All righty. Now, just real quickly, I want to go over this very, very quickly yet again on navigating the control panel. Okay. Make sure if you want to be able to get through here, if this is your first time, click on that arrow, that little orange arrow there to expand, and you'll see this hand. That's going to be how you ask questions. All right, that's how you raise your hand, so I know that you can hear me. In the area to ask questions, there's a little questions and chat section down below. When you expand the channel, okay, you get your audio section, any handouts that we might have, which we don't have any this evening, but the question and chat section, that's where you're going to ask your questions, and that's where you're going to type in your answers for the heat load. All right, and then again, this is a little bit closer. Like you just type it on in there, and then we'll see your responses. So what I'd like you to do then is to again, if you haven't done it already, just type in a hey, hello, how are you? A lot of you guys have already typed in your responses for your best thought, what you came up with when you did the heat loss analysis. I can see a couple of guesses here. I know they're guesses, but some of you guys did your own heat loads. And Logan asked, are we going to do a breakdown of each room? Yes, we are. We'll give you the different areas of heat loss for each individual room. But I just want to make sure everybody understands this is how that works. So that's how you're going to be asking your questions. So again, last week we got started on this whole house heat loss. This was the first floor, and we kind of gave you all of the charts and graphs and worksheets to use that were in that handout. So you could do a real honest to goodness IBR heat load. We showed you things like where to find the outdoor design temperature in the different tables. We showed you where to get all the U values for walls and windows and doors and ceilings and basements and all that other cool stuff. So all of that stuff was there for you to be able to fill out the worksheet and complete a heat loss. And this was our completed heat loss for bedroom number 1. I believe that was bedroom number 1. And we came up with 2,880 BTUs for that specific room. So last week we did bedroom number 1, and then we also did the basement. So we're going to be going through the rest of that house today. So this week we're going to review the totals, and we're going to be looking at some heat emitters, including radiant. All right, we're going to be looking at some heat emitters. Boilers we're going to look at next week. We're going to specifically talk about boilers for next week. So let us continue. Let's get moving on here and get to work with I guess if we were all Back to the Future characters, who would be who? My thought is Dave is going to be George McFly, because Dave is your density, right? Rick, Who would Rick be in Back to the Future? Doc Brown. You're more of a Doc Brown kind of guy. Me,
Okay.
I figure I'm the protagonist who gets the girl. I got to be Marty, right?
Okay.
Sure.
And who's Biff? Well, that's a good question. Who's Biff? I'm going to say Messenbrink. That's all I'm going to say.
All right.
Anyway, so let's do our totals for that first floor. Okay, we had bedroom 1. There were 2 bathrooms. We'll do each bathroom individually. Family room, kitchen, dining room, living room, entry, and then bedrooms 2 and 3. We did not do a heat loss on the garage. We could, but we did not in this case. So let's take a gander at what we came up with. Now we already had 2,880 BTUs for bedroom number 1. Now bathroom number 1, what we came up with there, it's a small bathroom. It's only 4.5 feet by 10.5 feet. It's a teeny weeny little room. So you had your infiltration, you had very little ceiling loss. You had 1 window and that 1 wall loss. And that had a total of 832. Now, this being an IBR heat load, what they did for you was what they want you to do is to simply add 20% to that number for the wet and naked factor, right? When you're in a bathroom, you're wet and naked. So they'd rather you get that extra 20% so you're warm, wet, and naked. So that's kind of where we came up with that. And we walked through and we came up with 998 BTUs for, for bathroom number 1. Now, bathroom number 2 has no outside walls. So you would think, don't have to do a heat loss, but you still want to put something in there, right? You're still going to want to put something in there. And this is what we came with. There's no infiltration. You had 62 BTUs worth of ceiling loss, no windows, no walls, 62 BTUs total, and add 20% to that, 74 BTUs. I mean, you walk in there and you've overheated it. So I don't know. I'm going to ask Dave and Rick, what would you do in that bathroom? What would you do for heating in that bathroom?
Have we figured out what the heat emitters are yet?
No. I mean, we could do anything we want, right?
Okay. Yeah.
If it was
I'd
fin
do the
tube
floor.
baseboard, a foot maybe.
Yeah, and look at the wall space. You'd have to put it behind that door or behind the toilet, or
Yeah.
see, maybe again, it's not forced air, so we can't really do. We could do a toe kick, a hydronic toe kick, but that'd be that'd put a lot of heat in there. It would have to be on
that'd be
its own
way
thermostat.
too
Yeah.
much. A
Yeah.
towel warming radiator is a possibility. I mean, at
Yeah.
that point, a heat lamp might be enough. Seriously,
Yeah.
if you think about it, that's one of those weird little things. And if you had radiant, that would probably be the easiest thing to
That
do,
would be
right?
the best.
That would simply be the easiest and the best thing to do, just to keep that
Yeah.
thing, keep that thing not cold, keep the floors nice and warm. So yeah, leave the light on, says Dan Cook. That'd definitely do it. 74 BTUs is not a whole heck of a lot. So but you got to have something in there. Got to have something. So that's bathroom.
Put the coffee pot in there.
Yeah,
Put the coffee pot.
There you go. Or a candle. I don't know, something like that. So there's the 2 bathrooms for you. Now, let's look at the family room and kitchen. And we decided to make these, even though it's one big room, we decided to look at it as 2 separate rooms. So for the family room, we had 1,400 for infiltration, 261 ceiling, 844 door, and 432 wall, for a total of 2,900 BTUs in that room. And you'll notice right here we have a sliding glass door. So if we're going to use baseboard, we're going to have to split it up here and here, all right? Or we'll figure out something else. For the kitchen, now the kitchen's going to be interesting. For the kitchen, we're looking at a total of 2,900 BTUs. Now, again, there's really no outside wall space for a piece of baseboard unless you put something right here, perhaps. So again, you're looking, as Rick mentioned earlier, a toe kick heater under the sink, or we're looking at radiant floor heating or something along those lines. Okay. So, both of those that's really how we'd have to look at the kitchen. You have a door to the garage, so that's going to add some heat load, and then you get your stairs to your stairs going down to the basement, etc. So yeah, you're looking at about 2,900 in both rooms. All righty, let us continue and let's look at the living room and dining room. Again, these are half walls, right? These little dotted lines are kind of like half walls. So again, you can look at it as one big room or two smaller rooms. The heat load's gonna come out to be about the same. We chose to break them up. So we've got 2,035 BTUs in the dining room, it being a little bit smaller, 10 by 13, and then 16 by 13 for the living room. Now we're looking at about 2,800 BTUs. So again, you could look at some baseboard here and some baseboard here, or radiant floor heating, etc. Now, one thing I want to ask you guys, and also ask the folks out there in webinar land, this wall goes up against the garage. Now, we didn't heat the garage, but is the garage considered a cold outside wall, or is it considered something differently? I know how I did this. I'm just wondering how you guys would approach this, both Dave and Rick.
The way I would do it, I would treat it as half a wall.
Half a
So
wall.
I would just take the dimension of 13 feet, cut it to 7.5, and call it a day, just to get some sort of load on it. Because if you leave the garage door open all day long, you don't want the rest of the house to suffer.
Right.
Terribly. Yeah.
Right. Rick, how about you?
I'd heat the garage, but
why I love
even here in Sandy, Utah, I'd heat the garage. But Alaska, we had heated garages, and I'd probably maybe do the set point temperature on that side at like 50 degrees or something.
Mm-hmm. Okay. Yeah, you certainly could heat the garage. Absolutely. If you didn't heat the garage, how would you treat that wall? I'm on board with what Dave suggested, and that's the way I did the heat loss here, was consider that a 6.5 instead of a 13-foot wall, consider it a 6.5-foot wall, because it's not going to be 0 out there or 7 degrees out there. If they shut the door, and if they don't shut the door, well, it's on them, kind of thing. So there's really no wrong way of doing this. You could consider it a completely cold wall and say, hey, worst case scenario, they leave the thing open. I'll put a 7-degree wall. Put it, consider that an outside wall at 7 degrees. That's perfectly acceptable as well. Is that right? And then so we have the entry and then the 2 bedrooms. So the entryway with infiltration, the main in and out, the main entryway, we always figure at the highest rate of infiltration, and you only have to pick one door for that. Usually it's the main entryway, and that was done, I think it was to a 0.027 infiltration factor. If you were with us last week, you'll remember that. So that's why we had that 995 BTUs worth of infiltration for such a small area. In your ceiling, door, and wall, that came up to about 1,400 feet. And again, if it was a hunk of baseboard, you'd have to put it right there. Bedroom 3 being, you only got about a 13-foot outside wall, taking that closet into account. Okay, not a huge heat load there, only 1,600 BTUs for that bedroom. And then for bedroom number 2 with 2 outside walls, that was up to about 2,600 BTUs. Again, not a lot of heat load in all of these different rooms. If you take a look at bedroom 3, 1,679 BTUs, you might be talking a 3, maybe 4 feet of baseboard in that room. I remember we taught this class a long time ago at our factory, and we came up with about 3 or 4 feet of baseboard. One guy says, "There's no way I could do that. It won't work." I said, "Well, you just did the math. Of course it works." He says, "No, I couldn't in good conscience only put 3 feet of baseboard or 4 feet of baseboard in that room. I have to put 10 feet of baseboard in there." I said, "Okay, the numbers are the numbers, man. The data is the data. We didn't make this stuff up, but there's that, I don't know what it's called. I think it's called cognitive dissonance, where your brain can't believe what your brain won't accept what your eyes are telling you, what reality is telling you for whatever reason. But that's the number. It's not a big heat loss area. Okay, it's not a big heat loss area. So that's the entire first floor. All right, I'm hoping that kind of jibes with what you guys came up with. Now let's total it all up. Okay, so the entire first floor, we add all those rooms together, and we came up with about 20,391 BTUs for the first floor to go along with the 10,186 in the basement. Total load there was 30,577 BTUs for that entire job. Now, again, last week when we just asked you guys to take a guess, to give us your best estimate based on your experience, most of those, do you remember where most of those were in the 70,000 range, weren't they, Dave? Most of the responses?
Yeah, we had, I think we had 55,000 as a choice, 76,000. So yeah, we had, we had quite a few number in the 70s range. Yeah.
Yeah.
It was neck and neck between the 55 and the 70. There was only a handful of guys that chose the 110,000. That's just because they had a big ass boiler that needed to sell.
Yeah. So here's a house. It's about 2,400 square feet, 22 to 2,400 square feet, 30,000 BTUs, less than 31,000 BTUs. So that's just crazy. That's just crazy. Now I got an email today from a guy who did it by hand, and he came up with around 31,000, close enough, because how you measure things is going to make a difference. And if you're a little generous here or generous there, that's going to make a difference. But he also say again.
I found it. I was looking for it.
Okay.
So right there on the camera, if you see, that's what the numbers were. So 20% of the people chose the 81,000, 31% at 55,000, 5% at the 101, and 43% at 67. So
wow. Okay.
Yeah. Yep.
Yeah.
And those numbers were the choices, Dave?
Yes. Yeah. Those are the choices that I put up for the poll last week.
Oh, okay. Interesting.
So again, what do your eyes tell you? What does experience tell you? And when you actually do the math, when you actually do the math, you will find that there's not a heck of a lot of heat loss here. Now, if you wanted to figure out a boiler, you're going to have a hard time because nobody makes a 30,000 BTU boiler or 31,000 BTU boiler. You're going to be picking a boiler, the smallest boiler you can that's going to do the job. And if you're making domestic hot water, well, you have to take that into account as well. So there's a lot of different things to look at. But the email I received today was a guy asking, he did a heat load with using the handouts, and then he did a heat load using our Flow Pro Designer software. And they were very different. There was about a 10,000 BTU differences. Why were they differences? Well, it could have been a lot of things. Most likely with software, if you don't get in and change some of the defaults to match what you're using on the pad of paper, then you're going to get different numbers. You got to be very careful with software. If you don't really get into the software and make sure you're using all of the right numbers and all of the right values, especially for infiltration, you're going to find that you might be a little bit off. You got to know how software isn't one of those things I just stick in the numbers and it does all the thinking for me. Software, you got to know what you're doing.
Yeah.
You got to, not only do you have to know how to do a heat loss, you have to know how to use the software to do a heat loss. So it's two different things. People think, well, I don't need to know this crap. Just give me the software. No, man, software is just a fancy calculator. If you don't know how to put in the right information into that calculator, it's not much of a tool. It's sort of a convenience item. So you still need to know what's going on here and how that particular calculator works and how it arrives at the number it arrives at. So anyway, so 30,000 BTUs, 30,577 BTUs. Does that number surprise you guys? Now I know a lot of you who did the math, you were kind of in that ballpark. So we had a lot of good answers within that ballpark. So we'll be able to select a winner from a handful of guys that came up with the number that was reasonably close. Because again, whether you're going to get exactly that number is going to depend on blind luck, and it just depends on how you round things up or round things down. All righty then, very good, very good. So again, here's our totals, 30,577, which brings us to, before we take a quick break here, I want to hit the Takeo movie trivia question of the night. And again, as we said, our movie is Back to the Future 1, 2, and 3, but this trivia question comes from Back to the Future 1, the original. And in the original, in Back to the Future 1, Marty's band auditions to play at the big school dance, but is rejected because they are, quote, just too darn loud. So the trivia question is, what is the name of Marty's band and who played the teacher who turned them down? Who played the teacher who said, I'm sorry, boys, but you're just too darned loud? So there's your trivia question for tonight. What's the name of Marty's band and who played the teacher who turned them down? There we go. Bill Buckley had a very interesting question here. What about safety factor? In different software will have safety factors. In the Takeo software, there is actually a user adjustable safety factor, which is a fancy way of saying fudge factor, you know, and you can put in a percentage. Say, hey, whatever this thing comes up with, add 20% because I just don't want the phone call. You can do that. And it depends on how much you put in. You could set it to 0, you could set it to 20, you could set it to 50. I had an engineer once, I had to do a heat loss for an engineer once, and he said, I don't care. This is an engineer, a man who has been to school, has a license and a diploma and all that stuff. And he said to me, I don't care what you come up with for a number for a heat loss. I don't care. Whatever you come up with, double it. And I looked at him and said, beg pardon? He said, double it. I've been in this business 35 years. I haven't been sued yet, and I'm not going to be sued now. So if you don't double it, I'm not signing off on it. It's okay. It's your name, buddy. Whatever. You know, it was, by the time that job was sold, it was physically impossible for us to have put more tubing in that house. I don't think you could have fit more tubing in that house. But hey, that's the way it is.
Yeah. Well, Charlie had an interesting comment too, and he says, probably gonna have to size the boiler just for the DHW load, not for the heat load. You know, and that does become true nowadays. You know, we look at that, and the boiler is a lot of times being sized just for the domestic hot water load than it is for the heat load. Yeah.
Indeed, indeed. All righty, so let's get back to work here, and guys, type in your answers now. Again, you have to have the name of the band and who played the teacher. The name of the band and who played the teacher. One or the other doesn't get you there. You got to have both. All right, very good, very good. Now, I want to talk about baseboard really quickly, and then I'm going to turn it over to Dave for some talk on Radiant. Let's talk about baseboard. Baseboard, everybody has their own favorite number that they use for baseboard, BTUs per foot, right? What number do you guys use? When you type in an answer for me, when you're doing baseboard, we always go, yeah, 600 BTUs a foot, 500 BTUs. What number do you use? You know, what is your go-to number for BTU output per foot of baseboard? For most people, it's either 500 or 600 or something like that. Yeah, we've got some answers here from Dan Cook and from some other guys, 550, whatever it might be. It's your go-to number, right? It's your go-to number. Now, what do you base that on? What water temperature do you base that on? Let me hear you there. 180 degree water, says Nate. 180 degree supply, or 100? Is that 180 degree supply, or do you base it on the average water temperature? On the average water temperature. It's an interesting question because everybody's output chart for every company, all right, every one of them, they're going to give you the BTU per linear foot based on the average water temperature. So if you're picking 180 degrees, all right, if you're picking 180 degrees and either 600 or 570 for output, all right, you're planning on sending out, if you're designing to a 20 degree delta T, you're planning on sending out 190 degree water, and on the 20 degree delta T, the return water is going to be 170, ergo the average is going to be 180 right here, all right? So if you are using 180 as a supply water temperature, well, then your average water temperature is now 170 because you got 180 going out and 160 coming back. Now your average is 170. So take a look at these numbers, all right? Take a look at the numbers from 170 and from 180. They're different. You'll also notice two output rows for flow. One is for 1 gallon a minute and the other is for 4 gallons a minute. Which one do you use? Well, the cool thing that you'll always find is the output is information down here. All right, you always get information down here in the notes. So right there, number 6 tells us the IBR ratings at 4 gallons a minute should not be used unless the flow rate is known to be equal to or greater than 4 gallons a minute. Well, we don't know what the flow rate is yet. Where the flow rate is unknown, use the IBR rating of 1 gallon per minute or 500 pounds per hour must be used. I don't know why they go into 500 pounds per hour. 500 pounds per hour, if you divide 500 pounds by 8.33, that's what 1 gallon of water weighs. You get about 60 gallons. All right, so that's 60 gallons an hour. That's 1 gallon a minute. Okay, good. But that's kind of where all that comes from. So what this is telling us is if we don't know the flow rate, we got to use the 1 gallon a minute number. We got to use that number at 510. If we were just not thinking and we picked 180 and 600, but boy, 600 BTUs per foot, that's a darn good baseboard right there. We're maybe 20% off in our output. Not that, I mean, just so you know where the numbers are coming from. All right. So you might be 20% off in your output. All right. A couple of other things. You'll also notice we have 3/4 inch baseboard and 1/2 inch baseboard, and you'll see the output is actually greater for 1/2 inch element than it is for 3/4 inch element. Now, does that surprise you? It shouldn't, because the answer can be found here. The output is based not upon the size of the pipe, but it's based upon the unit itself, the assembly itself, which includes the size and concentration per foot of fins. All right. So 1/2 inch baseboard, if you look at line 4 there, 1/2 inch baseboard actually has 57.1 fins per foot. Now, I haven't seen that 1/10 of a fin, but you get the idea. Whereas the 3/4 inch baseboard has 51.8 fins per foot. So we get more fins per foot, and they're a little bit bigger on the 1/2 inch baseboard. Now, the difference is going to be how long of a run can we, or whoa, how long of a zone can we have? We're about 17 to 20,000 BTUs max on a 1/2 inch line. You're up to 40,000 max on a 3/4 inch line, just so you get that. So those are some of the differences. Again, and that again, 4 gallons a minute, and don't use 4 gallons a minute unless you know your flow rate's going to be at least 4 gallons a minute. And another thing I always find interesting, people get wrapped up around flow, is in just looking at the 180 number, just as an example. At 1 gallon a minute, I have 570 BTUs worth of output. If I increase that flow rate 4 times, all right, quadruple the flow rate, I get about 5% more output. All right. So I've boosted the flow rate 4 times from 1 to 4 gallons a minute. I get about 30 more BTUs per foot. Just so you understand. Zarighty. So real quickly, bedroom 1. We wanted 2,880 BTUs per foot, and we're going to use that 510 BTU, 2,880 BTUs, 510 BTUs per foot. We're looking at about 6 feet of baseboard right there. All right. For the bathroom, 998 BTUs per foot. Yeah, we'll throw in a 2-footer and call it good right there. So there we have baseboard for both of those rooms. Now, here's something we can do with lower water temperatures. All right. Slant Fin, being very smart, has actually rated its baseboard down to about 110 degree average water temperature. All right. So let's say I want 130 degree average water temperature under design conditions, meaning the water goes out at $140, comes back at $120. My average water temperature is 130. So I'm looking at 240 BTUs per foot. Okay, so lower water temperature, I'm going to need more baseboard, right? Well, how much more? Let's figure this out. 2880 divided by 240 BTUs per foot. Now I'm looking at a 12-footer. So I'd pretty much cover that outside wall right there if I wanted to, okay? And in the bathroom, I'm going to need about 4 feet. So I'm going to need a little bit more baseboard in there, okay? So about twice as much baseboard at a lower water temperature. It's not a bad thing. Now I can use a condensing boiler, and I know that boiler is going to condense pretty much all the time. So what's the downside? There really isn't one. Alrighty, with that, I mean, there are other options. There's panel radiators, of course, and we can talk about those next week. There's radiant floor heating, which we're going to talk about this week. In fact, we're going to talk about it right now because I'm going to kick it over to George McFly. Dave, you are my density.
All right.
Dave, I am your density, Holdorf.
I am your density.
I am your density. We love you, Dave.
Oh, thank you. Hey, one of the questions came in from Logan before about baseboard, and he said, do we always place it under the window?
I mean, it's a good idea where you can, yeah. I mean, that's where, you usually want, a lot of people say center it on a wall underneath the window because that's where most of your heat loss is going to be, right? So if you can, yeah. I mean, if you got 2 outside walls and each outside wall has a window, take a
one.
pick, you know?
Yeah. I mean, I usually talk about that there too, because that's when you get that washing effect. So that the cold air coming off the glass, it feels like cold air coming off the glass when you got the warm air going up, and that helps it also stratify into the room too by getting it in front of that window. So just hopefully no furniture there, right? Yes, furniture
Right.
at least 18 inches away.
Yes, you need 18
18
inches in front of
inches.
baseboard.
Yes, not slammed up against the wall.
Yeah, why
All
isn't
right,
this
hang on.
heating? Well, all right, I have made you the presenter, Dave, so you'll need to share your screen.
I see that.
Oh, and I see you sharing your screen.
I got to choose the right screen. Hang on a second. There we go. Oh, darn it. Hang on a second. Got to change setting.
George McFly was not prepared.
It's too many monitors.
2 minutes, yeah.
There we go. Now I got the right one.
All right, atta baby.
There
Rock
we go.
and
That
roll.
that looks better. That looks better. Okay. All right. So let's get in the world of radiant design. So, like John was saying earlier, that Rick and I and John also got a lot of years of radiant behind us before coming on board at Taco. So I started off in this industry doing tech support and designs and doing radiant way back when. And my original heat loss software was a spreadsheet. So not much more different than the hand calculations that we've been doing today. But we used to do a spreadsheet before all the software started coming out. Then the software all started coming out and started doing a lot of designs that way. I think I averaged around 8,000 designs a year when I was heavily into it before I got on the road doing training classes. So seen a lot of designs over the time. So let's talk about radiant design, simple radiant design. And we're not going to get involved in the install methods as in how to install the different ways, but we want to go and get the numbers that we're looking at here. So this way, when you get to a job site, you can always take a look at the design themselves. So simple radiant sizing here. I broke it down, this presentation, down to more or less 6 steps. First step actually, step 0 is doing the heat loss. That's done already, so we're not going to worry about that. But now we need to find the BTUs per square foot that the space is going to do. Number 2, we need to find out the finished floor in the space. What is the floor covering if we're doing radiant floor heating? So whatever's covering the radiant system. Step 3 is going to be looking at where the radiant is going. All right, like what type of system we're going to install. We'll talk about those different systems and also tube size. So those two are related to each other, as well as the next step is what's the surface temperature? How hot is that floor going to get? And step 4, which is a 2-parter, so to speak, it's they play around with each other. You mess with one, you change the other. What tube spacing, what supply water temperature do you need for that system? So those are all related to each other. So that's why step 4 has those. Step 4 has the asterisk behind it. Step 5, how much pipe? How much pipe is going to end up in the space itself? How long are your loop lengths going to be? And then step 6 is what's the flow and head that you need for your system. So these are more or less your steps to getting a simple radiant system designed out. And then there'll be more later on after that, as in it comes to your piping strategies and mixing and controls and all this other stuff after that. But this is just looking at your basic design on your radiant system. So for review, as we already did, all right, our project here is looking at the first floor. I am only going to concentrate on bedroom 1, and I am also going to concentrate on the basement for 2 different types of installs, 2 different heat loads. We'll take a look at that. So your heat loss calculations. All right, for bedroom 1, as we saw already, we saw 2,880 BTUs per hour for the bedroom 1, and the basement was at 1,388 square feet. At 10,173 BTUs per hour. To figure out your BTUs per square foot is really simple. We are just going to figure out how much heat we can get out of 1 square foot of floor. All right, it's 1 square foot of floor, which is basically taking the square footage of the room, divide it by the square, take the heat loss of the space, divide it by the square footage, and you find the BTUs per square foot that you're going to get out of it. So bedroom 1 gets 18.8 BTUs per hour per square foot, and the basement is 7.3 BTUs per square foot. So as you can see, the basement, very low heat loss. It's got a heated second floor, so your BTUs per square foot are very low there. All right, so now we jump into step 2, and step 2 is looking at now what floor covering you're going to put in there, because that can now start affecting our surface temperatures. But these are conversations you need to have with the homeowner. We need to find out what type of floor covering they're going to put in this space. And because that can change your design aspect and also going to change maybe even how you pipe out the mechanical room based upon water temperatures and things like that. So there's lots of different charts all over the place. You can do some searches for them, check the manufacturers. But also, as the heating guy, we can also make the recommendations for what type of flooring to go into the space itself based upon the different R values. So why do people put a lot of carpet and pad in their homes? Because they don't like to step on cold floors. Okay. So, but hey, guess what we're doing? We're heating the floors. So, but when we put carpet in here, if you take a look at some of these numbers here, carpet and pad, you know, the jute style system, all right, does have quite a high R value, 3.88 per inch. All right, just for the pad itself, you know, your typical R value 1.9 that we're going to see out of it. So the lower the number, the better it is for the radiant system. So when we look at oak flooring, 0.6, maple at 0.638. So we come up and take a look at tile is 0.4. All right, very low, very dense. So the denser the material, the lower the R value that you're going to see out of it. And you're also going to see in here plywood and OSB, because that could also be your subfloor if you need to heat through that. So we need to pay attention to that. Whoa, I didn't do that. So we take a look at bedroom 1, all right, which we have a 3/4 inch plywood and a 3/4 inch oak. Right now, I do know we're going to go under the floor with this system. So you need to take a look at what the R value for the plywood is. And the basement floor, we're going to do a laminate floor, and we're going to do a laminate floor that's also going to have that, you know, what they call pergo pad, you know, that little styrofoam pad underneath it, so it doesn't sound and feel so solid. So you add those up and you find the R values for each one of those. And that's going to, we're going to use those numbers in a little bit while we start moving along. All right, so your install methods, which way you're going to pick. And we could change them as you go through in some applications. Like I said before, make the radiant fit the house. Don't change the house to fit the radiant. So you want to look at, maybe you can change a couple of different methods based upon the install, but you've got your slab on grade, slab below grade. One of your advantages here is you get flexibility in tube spacing. And if the concrete's already going in, get the tube in there before the concrete cures. Most important. Your thin slab, all right, could be a gypsum style based flooring. So you're going to have a suspended floor, meaning you've got a plywood deck and they're going to do a thin pour or a thin slab on top of that. And that could be used for lots of different reasons, for sound deadening, for strength purposes. And we go ahead and put the tubing down and pour it encapsulated in a slab, very similar to a slab on grade or below grade, but of course a lot thinner. We're looking at maybe 1.5 inches thickness compared to a 4 or 5 inch thick slab. And then you've got your between the joist systems from below the floor. So you're going to see a plated system where the plates are going to screw up tight to the underfloor, and then we snap tubing into that. And then you also have your suspended method, where now it's no plates, and what we're doing now is heating up an air pocket, which then heats up the subfloor. So 2 different ways to do it from below the floor. We'll explore that and take a look at the numbers. And then there's your sandwich style system. So there's a lot of different sandwiches out there. Some of them are structural floors with the tubing cutouts in there. Some of them are, you sandwich it in between a subfloor and the finished floor. So there's a lot of different methods that are out there. They also have different tube spacing. When you're between the floor, between the joists, your tube spacing is your joist layout. So you don't have a lot of flexibility in changing your tubing spacing. But when you got thin slabs and slab on grade, you do. Some sandwich methods allow you to change the spacing. It will depend upon the system and the manufacturer itself. All right, so now we jump into step 4, and let's figure out a couple of things off of these charts. And so you pull up these charts are going to be from your different manufacturers. And this one here is using aluminum plates, C-fins. These are heavy duty extruded plates from below the floor. Mr. Pex has this one. And you're looking at a couple of things here. You see across the left-hand side is your BTUs per square foot. Along the bottom of this chart is your supply water temperature. And then your diagonal lines are the surface above R value. And then on the right-hand side, we're looking at a surface temperature. So if we were to take a look at the bedroom, at bedroom 1, which was almost 20 BTUs a square foot, let's just call it 19 BTUs, right here is our 19 BTUs per square foot. If we follow this straight across, you're going to see what the surface temperature of the space is going to be, of the floor. Okay, so it's just below 79 degrees. It's between 76 and 79. Let's just call it 78.5. All right, is going to be our surface temperature of the floor. This right now is regardless of the flooring that you have chosen. The floor needs to be 78.5 degrees in order to deliver 19 BTUs per square. But now we go ahead and take a look at the R value, and we had approximately 1.5 between the plywood deck and the hardwood floor on top. And where those two lines meet, we're going to drop a line straight down, and that says we're just about 135 degree water for this plated system from below the floor. Okay, so that's what we need here. So now you can see what surface temperatures. Now, is 78.5 degrees hot? All right, are people going to really feel 78 degrees? Gets kind of close. Your skin surface temperature is around 80. So you go and touch it and it feels a little bit cooler than your hands. It's not going to be hotter than you. So that's just something you make sure you let people know, let homeowners know what's going on. So it's not a super hot system. And if you start doing this on, so just remember that, and the lower the heat loss of the space, the lower the surface temperature is going to be. Now, if we were to change this one and decided to go with a suspended pipe method instead of actually using the plates, maybe we can do it from below the floor. So again, we're going to steal take that line for 19 BTUs a foot. And now we pull off the R value line. Now, this chart is important to pay attention to based upon the manufacturer, because this one says a 3/4 inch plywood subfloor has already been factored in. So you got to make sure you pull that out. So pay attention to the different manufacturers that you're working with. So this one here says already 3/4 inch there. So we just had the 0.6 of the oak flooring going in there. And if I were to go suspended pipe method under the floor, no plates, we're looking at 147, 148 degrees, 147 degree water. All right, so it is going to be a higher water temperature than your plated system. So, but just, it depends on what you got going on. So you have freedom. You can go higher, right? As you start looking at this chart here in this light gray mode, it says, if you're going to work up here, you better know what the hell you're doing. You better have some fudge, so to speak. Not fudge, so to speak, but do you have the room to operate your system at 165 degrees and more? At 180 in the dark gray, it's saying, yeah, your boiler's done. That's it. That's your max water temperature you should be putting out there. You could run higher, but you got to make sure you can handle it. And also the expansion, contraction, things like that can occur. And of course, a room with a hardwood floor may have other things thrown on top of that floor, like mini carpets or area rugs that take up 3/4 of the room. All right, if you don't take that into account and you're already at the 170 degree world, you don't have that flexibility to add some more BTUs into the space itself, other than with plates. So the lower the water temperature, I find, the better it is. One, for your flexibility, but two, the efficiency you can get out of the system. So if you had a condensing boiler, the colder the water, the more efficient the system's going to be. Now, if we jump for the basement space and we start taking a look at a concrete slab, 4-inch slab, and this chart happens to show us 12 inches on center, we come across and we find our BTUs, which was around 8 BTUs. We find our R value, all right, which was 1.2. And we come down and we see we're going to need about 83-degree water. 83-degree water to heat this basement space. Very, very low heat load coming out of a basement space. That's 12 on centers. So I've had people ask me all the time, well, what if the heat loss was really high in the space? Let me just put more pipe in the slab. More pipe in the slab doesn't do anything for you except install more pipe. That is it. It will lower, and at this stage, it's such a low number. So if we go to take a look at the charts for 9 inches on center and do the same thing, all right, we drop the water temperature about 3 degrees. Now, this is such a low load on this system here, in this application, this example that we created, but we're lowering it by putting in 30% more pipe. All we did is lower the water temperature by 3 degrees in order to heat the space. So that's one thing to remember about slab applications. The more pipe you put in, all it does is lower your surface, lower your water temperature. Now, the one space that I do try to put as much pipe as I can is typically a bathroom space. All right, nice tile floors, try to pack it in there, maybe 6 on centers, because you can feel those hot and cold spots in the floors. And usually it's the only room in the house where you're wet and naked at the same time. So if there's other rooms that you're wet and naked in at the same time, then design around those rooms the same time, the same way. All right. All right. Now, how long do you run your pipe is going to be based upon your choices that you have for your install method. So your spacing multipliers, which means we're going to take the square footage of the room and multiply it by this number to get you how much pipe can actually physically fit into the space itself. So if you did 12 inches on center, which means for every square foot of flooring, there will be 1 foot of pipe in there, your multiplier is going to be 1. 9 inches on center for your slab applications, 1.33. Your underfloor systems, all right, your joist systems, which are typically 16-inch on center joists, you're going to be 8 inches on center with the pipe. You're going to put a loop in each bay. So there your spacing is going to be 1.5. And then for 6 inches on center, maybe some older homes or even some newer construction where they're doing 12-inch on center joists. I've seen some houses that way. You're going to be 6 inches on center with your pipe, and therefore your multiplier is going to be 2. So for our examples today, we take a look at bedroom 1, 153 square feet, multiply that by 1.5, we get 229 feet of pipe in there. For the basement, at 1388 times 12 inches on center is 1388. And your max loop lengths is going to be all over the place. And there are general rules of thumb that people use. You can go one way or the other. Again, it's still going to be the same amount of pipe in a house. If you shorten the loop lengths, you just end up with more ports on a manifold and having to run, more connections going back and forth. But for 3/8 PEX, 200 to 300 footers, can't say you can't go longer. You could if you want to. All right, 1/2-inch pipe, so anywhere 250s to 350s. I've done longer. I've done 500s. It all depends on the math. So this is what we look at, typically residential style systems. So if you're trying to take a look at how long the pipe is going to be, let's say bedroom 1, we figured, sorry, keep on clicking buttons here. All right. All right, but what about leader lengths back and forth? So you might have a central manifold location in a house. So we need to run the pipe back and forth from there. That number that I came up with before was just what fits in the square footage of the room. But now we got to go back and forth to that manifold. So let's say Bedroom 1, we happen to be 25 feet away from where the manifold's going to be. So we need to add that into the length also. So we see we had 229 feet of pipe in there. That might work as one loop. But if we're looking at our 300 as a max or 250 as a max, you might want to break that down into 2 loops. So 115 feet of pipe for each loop is going to fit in the space itself for 2 loops, and then add the leaders to that. So we end up with 265-foot loops. And that's counting the leaders in there. So the 115 plus 50 feet, 25 there, 25 back, you're good. And in the basement space, typically our manifold is going to be right next to the boiler room. So maybe 5 feet away, let's just call it. So at 1388, let's take a look at, if you're willing to figure it out, if you want to say, hey, I want to try to use 1,000-foot rolls on this project, and that means my maximum loop length is going to be 333 feet because that's 3 loops out of a 1,000-foot roll. Divide the linear footage by 333, it'll tell you how much pipe you can get away with. And the number comes up at 4.16. Well, all right, let's just call it 4 loops instead. And instead of it staying to 333s, I'm at 347 instead. So we may have to take a look at maybe buying loop lengths in a different configuration. So I can do 4 loops instead of 5 loops, because then the 5 would be a lot shorter. So like I said, it's just the same amount of pipe is going in the space. It just may depend upon the ease of install, the number of loops on a manifold, things like that. So if we're 5 feet away, add an extra 10 feet, 5 there, 5 back. And so the basement is looking at 4 357-foot pipes. How we doing so far, everybody? Feeling good?
Good. Good.
Okay. Any questions out there?
Not as of yet. You're covering it beautifully.
Okay. All right. Ask away if you guys are out there. All right. So, wow, we're on step 6 already. I've been flying along. I guess I got about 4 minutes left, huh? So, bedroom 1, let's take a look at the flow and head of our system here. We got to find our gallons per minute, and we also got to find our head loss of the system so we can size our circulators. So bedroom 1, hey, we're going to come back to the universal hydronics formula again. So GPM equals BTUH divided by delta T times 500. But today, radiant is going to have a 10-degree delta. We like to have a shorter delta T. John was talking about a 20-degree delta with the baseboard before. But with a radiant floor, we like to do a 10-degree delta because we want to have a more even surface temperature in the space itself. When you have a 20-degree delta, and let's say you only have 1 loop in a space, it's going to feel warm on one side of the room, floor temperature, compared to the other side. So if we stretch it, so if we bring that delta T a little bit closer, it evens it out. It evens it out in the space itself. So we have a 10 times 500 today. And 2880 divided by 5,000, my gallons per minute comes in at 0.58. We take a look at the basement space, same thing, universal hydronics formula, 10,173 divided by 5,000, and my flow rate comes in at 2 gallons a minute. Now this is total flow for the space. What's the flow per loop? Well, now we have to go ahead and take a look at the number of loops in the system. We split it up. So 0.58 gallons a minute, divide that by 2 loops, we end up with 0.29 gallons a minute. Very low flow rates. Radiant is usually very low. Half a gallon a minute or less is what we're looking for a lot of spaces. The basement space, we do the same exact math, 2 gallons a minute, divide that by 4 loops, we're looking at a half a GPM per loop. Now, we need to calculate the head loss. And taking a look at the head loss, now remember that on a manifold, all of these loops are running in parallel with each other. They're not in series. And if all the loops are the same length, all right, or really darn close, we only need to figure out the head loss of the longest loop for that manifold right now. All right. So this is a chart from Rahal, which is showing us our gallons per minute. It also has a velocity, and it also has your pressure loss and PSI. And man, I just messed everything up, and my calculation's coming up. but I will fix that. I just remembered I didn't multiply something here. So this is showing us in PSI per 100 feet of pipe. So let's zoom in on this a little bit so you can see it a little bit more. And let's take a look. Oh, I know what I wanted to bring up. These charts here from this manufacturer are showing us 60-degree water, 120, and 180. But we didn't have any of those water temperatures. So if we zoom in, let's take a look at our bedroom space. Our bedroom space that was looking at 0.29 gallons a minute. Let's just call it 0.3. And we pull this chart off. Which column should we pull from? The 60-degree column or the 120-degree column? Well, where I would pull from would be the 60-degree column. No, I'm sorry. No, we had 135 was our design temperature. So we're going to pull from the 120-degree column. The colder the water is a little denser than 135. So it's going to give us a little bit of our fudge factor coming into there. So we take a look at the pressure loss of 3/8 PEX. I like 3/8 for underfloor systems at 0.78. For the basement space, we're looking at a half a gallon a minute. We're going to use, again, same methodology. We don't have 80-degree charts to pull from. We're going to use the 60-degree chart, and we end up with 0.57. Which then says we come along to bedroom 1, 0.78 PSI pressure drop per 100 feet of 3/8 pipe, 0.78 times 140 feet, divide that by 100, and we end up with 1.09 foot ahead, and that's where my typo is, which means I need to take that number, multiply it by 2.31, and that is your head loss. So, you with me, right, Rick?
Yeah.
You agree with me? Yeah. I know when I did this, I'm like, oh, the head loss is low, and now I know why. I forgot one step there, the 2.31.
Well, they throw us curveballs. Some people do it with head, and some people do it with PSI, and we gotta watch.
Got to
it.
pay attention. Got to pay
Yeah.
attention to the charts. And I was jumping between different manufacturers, and everybody has their own way of doing it. We take a look at the basement space, same thing, 0.57 times 357. All right, that gets 2.1, which then is 2.1 times 2.3, which is about 6 foot ahead. So that is our designing a radiant system in a quick nutshell. Now, if that head loss is really high for your system itself, easy ways to change it would be to add another loop to the system. You add another loop, you shorten the length. So if you find your head loss went way high, you add another loop, the flow drops, obviously by one extra loop, and the system itself gets divided into that, and then the length also drops that way. So you have a couple of different options that you get to play with, and vice versa. What if you wanted to do 463 foot loops instead of 4 loops in the system? Your head loss would go up, but maybe it's going to match what your circulator has. So for example, in my house, I've got some 3/8 PEX in my house, a lot of it, and I have 350 footers. And I did it that way on purpose because I knew the circulator that was going in there that was going to be able to handle it. So I went with a longer loop length in the system, higher head, so I didn't have to choke the circulator way down. Right? And I got the circulator, I got more of a range out of my circulator in the modulation. I have the Delta T circulators in my house, so I have more modulation out of the system. So if you know what circuit you're using, you can also design your system around that too. So as we said before, I got to adjust that. That's your flow and head for bedroom 1 and bedroom and the basement space. Now these, you're going to tally these up as you have your different rooms throughout the house. So if you had this project that we're working on today and you did all the rooms in the house, you might start grouping them by water temperature, because every time you add a mixing valve into a system, you're going to throw in a new circulator. So once you do that, you start grouping those together, look at your flows and heads that you have in there so you can size the circulator accordingly. So I know in this system that I've already started, yes, the upstairs is going to be a higher water temperature. It's going to be its own mixing valve. The basement's going to also have its own mixing valve, and to calculate that out. So you start grouping them that way. But also, when it comes to your head loss calculation, I only showed the head loss just in the PEX tubing alone. Now you need to take a look at what's the head loss of a manifold based on flow rate. So different manifold manufacturers are going to have a different head loss based upon the flow rates. Don't forget the supply return pipe back and forth to those manifolds. So whatever pipe is being used there, your mixing valves, all right, which we covered off in one of our earlier sessions. Take a look at the CV of the mixing valve. What's the pressure drop through that valve? So that's also why we see a lot of those loop lengths getting shorter, you know, that 250 to 300 footers based upon putting a mixing valve in there, adding more head loss into the system to make the circulator do what it's supposed to do. And that's all I got in my time period. I only went 5 minutes over. Not too bad.
Very well done, Dave.
Not too bad.
Yeah. All right. Can you send me back the I'll change the presenter back to
The
me
screen?
now. Yep, there
Yes.
we go.
Got it back to you.
Show my screen. There we go. All right, let's get back to the show. We have a special guest too, guys. I do want to give him an opportunity to come up and say hello. Do that as soon as we answer the trivia question. Now, again, the trivia question was, what was the name of Marty McFly's band in Back to the Future? And who is the actor who played the teacher that said, "I'm sorry, boys, but you're just too darn loud"? Well, it's a lot of you guys got it. The name of the band is the Pinheads, or was the Pinheads, and the teacher was played by Huey Lewis of Huey Lewis and the News, whose music was featured throughout the first movie. So that was a nice little bit of a musical trivia there, music and movie trivia combined into one. So so pretty cool stuff. I know we had a lot of correct answers, so we'll be putting all the correct answers into that hopper like we did before, and we'll be able to select a winner for next week for our for another gift pack. Before we get on to going over last week's winners and stuff like that, I want to open up the microphone for a special guest. We were going to have this gentleman speak, we've had this gentleman's father speak a few times, and a lot of guys have asked, well, when is the next generation going to stop by and say hello? And one of the next generations is stopping by and saying hello tonight. I've opened up your mic. I'd like to introduce to the group Mr. Ben White. Ben, how you doing, man?
Hey, Ben.
Hey, gentlemen, how we doing?
Very good.
Doing great. It's a great Wednesday evening, isn't it?
Oh, it's just beautiful. I'll tell you what, and, I've been really enjoying this, and I don't want to, on cue, as I've been working from home for the last couple months, as soon as I start speaking on any type of audio call, the dogs start barking. It's just the way it goes, isn't it?
John knows
That's their
that.
job.
They've been speaking for the last hour, but which is nothing to say about the three of you, I promise. But no, I appreciate the time, and I appreciate the ability to sit in with you all and listen to this, and always learning, and just wanted to take an opportunity to say thank you to the three of you for, in my opinion, and I'm probably partial, but I think the best training team in the industry, and so thankful for the time that you all take to do this. I think one of the silver linings of this whole experience we've all been going through globally for the last couple of months is the opportunity to spend time like this and to learn from each other, and to take some time like this in a way that we hadn't done before on a regular basis. So, but really wanted to say thank you to the three of you, and also to everybody who's tuned in, taking time out of your evenings with your families to learn, to have some fun. I'm really enjoying seeing, Dave, I'm noticing the pattern here on the slides with all the nice looking cocktails in the background. I am partaking. I have a nice local IPA poured in my glass. So, but these are really great opportunities, and I really enjoy them. So thank you for that, and thank you to everybody for tuning in. This has been so great, and I really look forward to continuing this awesome forum with everybody. It's really nice to have this informal learning opportunity on a more regular basis.
I got to tell you, Ben, you were part of one of the more memorable evenings in the original Takeo After Dark series that you didn't know about it, but you were part of it. You were a memorable part of this. We had as you can tell, we have a movie theme for every night and a different T-shirt for every night. our movie theme that one night was My Cousin Vinny. And the trivia question that night was, what are the names of Johnny's two sons who are the fourth generation of white family leadership? And a lot of guys were trying to come up with the right answers, and the best answer we had, and we had to include it as one of the correct answers. One guy wrote in the two Utes.
I hope that was an automatic winner right there.
We had to pick that one. I mean, we had to put him in the hopper because it was just, the man was in the spirit of the evening. I got to tell you.
I think it was Dan Cook too, if I remember.
Was it Dan?
It was Dan. Yes. Yep.
Hey, Dan.
Yeah, all right, Dan.
I got to tell you, the great thing about the movie theme nights, right, is I came in a little late to one a couple weeks back, and I didn't realize that the theme was The Big Lebowski, and I can't remember if it was Dave. I'm going, why is he drinking, or maybe it was you, John. Why is he drinking a cold glass of milk? What is? Little did I know it was the White Russian, but
No, it was milk actually. It's like this. This is Pellegrino, all right. It's not a martini.
It looks so much fancier in that martini glass, my friend.
It does. It does. Well, let me ask you guys. Do you guys have any questions for Ben? From our audience, anybody out there that'd like to ask a few questions, because it's very, very rare you get a senior management and leadership to stop in on a webinar, and we really do appreciate it, Ben. And if you guys have any questions for Ben about TACO and the company and the future of the company, please, by all means.
Just a reminder too. Fourth generation is who you're talking to right now.
That's
so
right. That's right.
That's rare in North America to ever see a company do that. So anyway, just adding to that whole idea that this company is family owned, being run by family, and how many more generations? Who knows?
We're planning on.
Yeah, we're waiting, Ben. All right. All righty. Well, let's see. Okay, do we have anything coming in yet here? Let's go, folks.
Nothing's coming in too. Like I was saying to Davey Holdorf a little earlier. Definitely, I think our hope is in the next couple of weeks to get myself and my brother John the third, J3 as we call him, on here at the same time. So, hopefully we can sync up in that regard in the coming weeks.
Oh, that'd be awesome. That would be awesome. Because I've seen you guys, the two of you guys, when we had one of our award ceremonies, when the two of you guys are on stage together, it's like, it's a brother version of Burns and Allen, or Martin and Lewis. You guys put on a great show.
I'm surprised they continue to let us have the microphone, because I feel like we pushed the limits. That might be why they sit us next to the human resources table. I don't know.
Well, that's probably a wise move. Yeah, there you go.
I usually there are people always keeping an eye on you two at the same time, ready to pull it if they need to.
Probably a good idea.
Yeah. One question, because Ben, you're in new business development, right? I believe it's still at this point. One question came up about when is TACO going to make thermostats? I think I know the answer to this, but I'll throw it over to you.
Well, correct me if I'm wrong. We do make thermostats, correct?
We do for commercial applications, yeah.
Yep,
we do have actually a standard 2-wire heat only thermostat. Very basic switch thermostat. I have a couple at my house. I think 561, I think, is the part number, believe it or not.
Absolutely.
Yeah,
but it'd be worth maybe looking into broadening that offering for sure.
Very good. And this one from Dan Cook from Wild. Look forward to meeting you at the next industry event. Continue on with the great TACO culture and educating the industry. Remember, when something goes wrong with the system, blame it on the boiler.
Not the pump.
Not the pump. It's the boiler's fault.
Always the boiler. There's BTUs in there. They're stuck. They're not getting out.
Yeah, what's wrong? It's that boiler's thermally constipated. What are we going to do about it, Dan? That's the other product we need, Ben, is some Thermex lax. I keep telling people we're working on it.
Well, we can meet about that one offline, Johnny.
There we go. Wi-Fi thermostats, again, it's another question about thermostats. There's so many out there. The way I look at it, there's so many options out there. If we were going to come up with something, it would have to be something unique and different. So we have people looking at these things all the time. So it's going to have to be something unique and different. Otherwise, it's a Me Too product. And at that point, what's the point, right?
To set us apart, absolutely.
Yeah.
But along those lines, the Internet of Things and the connectivity of everything is something that we have a tremendous passion for right now at Takeo too. So, so you never know which way we're going to go with components in the future. So we are looking at things to say, connect together. So there will be connectivity, whether it's Wi-Fi, it's Bluetooth, like our circulators, things like that. There's a lot of Internet of Things that we're going to be tying into it.
Absolutely. As we move forward, I think every product that we're looking at, making enhancements to, or looking at new products, connectivity and the Internet of Things is definitely at the top of mind for sure.
And circulators you can watch YouTube videos on. That might be fun.
Hey, that wouldn't hurt. I'll tell you what.
When I need a mental break, I always go to YouTube and watch Don Rickles on The Tonight Show. It always makes me feel better.
Walk away from that not smiling.
There you go. All right, hey Dave, do you have the Wheel of Fortune set up for last week's winner?
I do. Whoops. I do have it all set up here actually. So you have to bring it back to me, or unless you want me to just turn my camera.
No, I will send this back to you. There you go. And our trivia question last week, I'm trying to remember what it was.
Darn it. Hang on a second. Got all these different things open up on my screen here. Okay. Let me open up the right screen.
Oh, that's right. It was the who sang the song, what was the name of the song and who sang the song that Vince and Mrs. Wallace danced to at Jack Rabbit Slim's in Pulp Fiction?
Right.
Do you know, Ben?
Oh, name of the song is escaping me. All I can think of is how much I love that movie.
Yeah, it's a great movie.
Yes, all right. So the winner of last week's trivia, let's hit the wheel and let's see who's going to win here. We had a bunch of names pull in here.
And the correct answer was Chuck Berry, and the name of the song, You Never Can Tell.
And I was messing around and I put Chuck Berry in. I guess I'm going to have to spin again.
It's Barry, not Barry, you guys. Dave, I think we're going to give this job to Rick now from now on.
I'll leave it with Dave.
So Dom has won.
Dominic. Dom Spadafora. Very good, Dom. All right.
All right. I will contact you, Dom, and let you know. You will see an email from us real soon. So excellent. Good job. All right. I will stop sharing my screen and send it back over to JB. Okay. And I am now the presenter, and is my screen still up? There we go. I got to show my screen. Okay. Yeah, and just a real quick look at next week. We're going to talk about zoning layouts, boiler selection, and things like that. And then we will have as our guest Patrick S. That's not his. It's not a letter. It's his actual last name, ESS, from Mondale and Associates. Going to talk to you about boiler treatment and water quality. And Patrick, one of the best I've ever seen at it. So he'll have a lot of interesting things to share with you. Hey, Ben, you still with us?
I am indeed.
We've got another couple of questions. One was about Takeo controllers. Will there be zone valve controllers and a pump controller combined? That's a good question, because when you put them together, you've got a product that costs more than either one by itself. So I'm wondering I guess I'll throw this one back to George. Would you be willing to pay more for one that was combined if it was just one? Or would you rather have the option of picking a less expensive zone valve control or a less expensive pump relay?
Great question. Yeah.
That's an interesting question, as opposed to a combined one. So I guess that we can throw that one right back. All right. So I'll wait for George to answer that one, and then and anybody else has a comment on that, please feel free to share. And I got this comment from Nate Warren. Thanks for taking the time to put this seminar on. I've worked for boiler manufacturers over 20 years and still learning something from everyone, and encourage me and customers and peers to tune in. So great, Nate. Absolutely. as many people as you want to bring on. I guess everybody out there, just tell your friends. We love having people come in and spending Wednesday nights with us.
Most definitely. Most definitely.
Yeah. So yeah, I guess that's the question on a combined zone valve controller and pump controller. I guess, I mean, Rick, what would you say would be the benefit of having a combined one?
Fewer SKUs, a lot of reasons, some of the same benefits that we're doing with ECM. You know, we have, like right now, we have 2 circulators, a 0018E and a 0034E plus. Those 2 circulators replace 108 circulators. So a reduction in SKUs.
You know, which is a benefit to us and maybe a benefit to wholesalers.
Wholesalers,
again,
contractors, everybody's benefits from just saying this device does lots of things. What do you want it to do? It does it. Don't worry about it. Just buy it. When you get out there, this is how you hook it up. If you think about it, all they are is relays.
Mm-hmm.
We send the right power to the right device. If we send 24 volts through a relay, it opens a zone valve. If we send line voltage, it turns a pump on. Pretty simple.
Yeah. Yeah, I guess again the question is though, if it's of a higher cost than just a simple like zone valve controller, would people buy it, or would they say, no, I'm just going to buy someone else's zone valve controller? That's always the fear. That's always a concern. There's going to be some of that.
The service guys, I could see service guys doing that, having a good combined unit, because now I don't have to worry about what job site I'm walking into, whether it's zone pumps or zone valves. I've got a controller if I need to replace. But if you're designing and installing and you know you can get a controller for dollars less, then you're probably going to get the dollars less, because that means more dollars in your pocket, more profit for you. So,
it's one SKU that you could have on the truck for a service call where you need something where you don't know exactly what situation you're going into. Whereas if you're designing the system from the start, or you know the application, maybe being able to specify whether you want that, pump relay or you want the zone valve control, you have that option to be flexible with it. So kind of maybe it's situational.
Right. And then therefore that makes us have 3 SKUs, a combined unit, a zone valve unit, and a pumper unit.
Yeah.
So
what did cousin Vinny say? Is a good ass kicking or $200? Which one you want? I don't know.
Hey, Ben, I happen to know that you're working on some things that have to do with what we call valves and accessories. Is there anything you can tell us on where that's going without giving away any secrets or anything?
Yeah, definitely. We're looking at enhancing some of the I would say the circulator accessory line in terms of some of the on the flange side of things, and trying to kind of give a broader product portfolio offering to the customer base. And our as we went through last year, a big exercise and really clearly revisiting and re-identifying as a company in conjunction with all of our customers and our suppliers and our employees, our mission, vision, values, right? One of those is, how do we become the easiest business company to do business with, rather? So we're really looking at a couple of different product lines that hopefully will allow customers to be able to interface with all of our products in this category on the residential side, and kind of give them a real package for pumps, flanges, and making their job in the field as easy as we can possibly make it.
Nice. Thanks.
Absolutely.
Very good. Hey, Ben, a little bit about your background. How old were you, and what's your earliest memory of Taco? I've always wanted to ask you that, because I mean, you grew up around this, when you were little. What's your earliest memory of being? When did you first realize that Taco was a thing, and what did it mean to you?
Probably my earliest memories when I was a little kid, probably 5 or 6 years old. We used to have the Taco holiday party in the factory every year. So every year in our commercial day, third day, we would clear it out. God bless the team that would be in charge of the logistics there. But we'd clear out that commercial pump line and set up a stage, and the Rhode Island Philharmonic would come in and do a concert. And my grandfather was very involved in helping coordinate that, and loved to get up there and conduct. So as a little guy, my brother and I both, just memories of running through the factory, which probably terrified our parents and everybody else involved, because there's a lot of sharp objects in there. But we would just being there with the Taco family, with everybody, started from a young age. And I would say, in terms of professional career, my brother and I at J3 both started, probably, in our teens, working on the maintenance crew, which is one of the best around, a great team, and everything from sweeping parking lots to cleaning toilets and painting the pipes in the ceiling of the factory, and we kind of worked our way through. So after working maintenance for a few years, we worked a lot of the different, almost all the different manufacturing positions on the floor, both in Cranston and Fall River. And both of us spent, after college, starting full time, a couple of years working in our tech support line. So if any of you ever had called in back in the day around 2012 to 2014, you probably talked to John or myself at some point. But was the best, I think, the best way to learn the product, learn how it's applied, and get a much better technical understanding of everything. And from there, I've done a couple of years working in project management, I should say. Was involved in the teams that developed at the time, the VR 1816 and what's now the 007E. And spent a few years actually down working for our branches down in Nashville, Tennessee, hydroflow pumps. So my wife Kirsten and I moved down there and lived there for 2 years, doing some product development with them, which was an amazing experience. And came back a couple of years ago and have been involved in the business development, the corporate development side of things ever since.
Good.
Very cool. How's your golf game coming?
Not well. It's not well this year.
Same here. I'm struggling with remembering which end of the stick to hold. It's the skinny end, right?
I'm hitting the ball often, probably more often than I'd like to,
Well, hey, it's good value then. You got a lot of strokes per dollar.
I'm out there to get my money's worth, JB,
I'm with you there.
Just every square inch of that course. As long as there's beer involved, I'm okay,
I had played around a while ago. One of the first rounds I played in a long time where I finished with the same ball I started.
Hey.
Next round out, second hole, I was 3 balls down. It's an unforgiving game. An unforgiving game.
Purples, apparently, right? The way she goes.
Yep. 18 chances of hope.
That's right. That's exactly right.
All right. Well, we had some questions about water quality. Again, that's something we're going to talk about next week. Any other questions for Ben or for any of us? Again, like we've done in the past, we'll stay on as long as you guys have questions regarding anything to do with hydronics, anything to do with TACO, anything that we can help you out with. We can talk about your golf game if you want to. We can do that too. But you guys have any questions? Again, please shout them out. I got another question for you, Ben. Between you and John, who would you say is the better looking of the two?
Well, because he's not on this, I'm of course going to say myself.
Well, yeah, okay, all right.
Although I'd probably say that if he was here as well.
I'm just trying to figure out how this information is going to help me at some point.
Blackmail is a very beautiful thing, huh?
Well,
Of course, it is recorded too. So
yes, it is recorded. So oh, there goes my dog. He's now he's barking.
Hey, Ben.
Yeah.
Of course, we know J3 is the namesake kind of thing, but where did you get, who were you named after? Do you know that story, or have you asked the folks?
Yeah, absolutely. So Benjamin was just Benjamin the first, if you will. There was no other Benjamins in the family. I think that name was just a name that my parents liked.
Yep.
But my middle name is Clark, which I'm named after that middle name is after my grandfather, Clark Stair. Who's amazing guy, passed away a few years ago. But that was the namesake after Clark Stair in Wadsworth, Ohio. Absolutely.
Nice.
Hey, Ben, this is John Masonbrink. How you doing, buddy?
Hey, good. How are you?
Good. I just want to, what's the age difference between you and your brother?
So John and I are, depending on the time of year, we're about 2 years apart.
Right.
So I'm 30, John's 32, and which I think has been good. You know, we get it's just far enough apart to be different, and just close enough to be best friends. So
Right
Well,
on.
Yeah, I know. I can't imagine, growing up and then, now into the business with your brother and slash best friend. It's got to be a great feeling.
you know, it's really it's amazing, and I think one of the best parts about it is, and I think John would say the same thing. We talk about this a lot. Is that we're both on our positions are in very different parts of the business. So John it heads up our OEM sales team and does a phenomenal job with it. Has been doing OEM sales for a number of years now, and I think John and I both have very different strengths, and that works very well because we both have the same interests, which is the health and success of the company and our employees. So that coupled with the relationship that not only the two of us have, and I know it sounds kind of cliche, but John and I, and it wasn't always this way, but John and I really are best friends, and so we're able to bounce things off each other, as well as the relationship that we have with our dad, who has always been so supportive, and he never pushed us into anything, but just been there to help be a guiding force, and help us learn and teach us. And that now, along coupled with Cheryl Merchant, who's just unbelievable. The four of us have a really amazing bond and a great connection, which has been, for my side, now I only speak for myself, but has been such an amazing learning opportunity because, I have so much to learn, and I recognize that. So I try to be a sponge, and, the last couple of years have been a great opportunity to really kind of dive in and be that sponge, but also, help contribute. And, just the team, the Takeo family is something I think unparalleled. There's, again, maybe I'm partial to it, but, it's really special because it's not just, the Takeo family isn't just our employees. It goes much broader than that. It's Takeo employees, it's our customers, our reps, it's the end users, it's the wholesalers, it's the engineers, it's everybody that's involved working together. And I think for myself at least, John and I both recognize how fortunate we are and lucky we are to be part of this Takeo family, and to have such an immense or a large group of people who have such a vast amount of knowledge that we can learn from.
Right on. Thank you.
Thank you.
Now the company's in great hands with, your dad and Cheryl and you guys and the three knuckleheads on the webinar here. I'm just proud to be associated with you guys.
That feeling goes both ways. Thank you.
Yeah, absolutely. Yeah, John, like I said, when it's funny that going back way back in March when you first contacted me about doing something together, we had just had internal discussions about doing this very thing, and it was very cool that we kind of it just organically grew from that to the point where those 2 weeks we were off, people were emailing me, says, why isn't there a webinar tonight? Why haven't I gotten anything? What's going on? So it's one of those things that worked out perfectly, and this is a great thing we can just keep right on doing.
Right on. Well, thank you guys.
Here's one question from George Conrad. When do you see Takeo classrooms up and running? Back at the factory. Boy, that I don't know. Ben, do you have any? Our factory, our facility's open right now for manufacturing. What's the latest on guests coming to our factory?
I'd say that one transparently is probably a little bit of a moving target, just because of the fact that this whole situation, this pandemic, everything COVID-19 related, is so fluid, and so every day is something different. I think, especially here in Rhode Island, we're moving in the right direction in terms of cases going down on a regular basis. But we have a team that's really been that's been meeting on a regular basis in terms of putting a back to work plan in place and kind of a playbook, and that'll we'll start to kind of have discussions about that moving forward. But it's kind of hard to say right now. One of the interesting things about this whole situation has been take the factory, for instance. We're at full capacity right now in the factory. Things are moving along great, but it looks different, right? We have plexiglass dividers up in between a lot of the workstations. We have people, spaced apart where possible. So I think and we've moved things around so that we allow the employees opportunity to when they're eating lunch or they're doing things, to be spread out amongst different parts of the building. So, when the training center will be back open, I don't have a good answer on that. We'll have to keep evaluating and looking at when, first and foremost, I think the importance is being able to look at the plan on bringing employees back where necessary, and then we can start to kind of evaluate when the right time to bring visitors back in the building on a regular basis is. The first and foremost is the health and safety of everybody, for sure.
Right. The other end of that too is at what point will people be wanting to like travel?
Right.
To come to a training class, whether they're local and just want to drive, or whether they want to fly in, because we would have people from all over the country coming to our training classes, and that's an iffy proposition looking in the near future anyway. So I mean, we have not canceled our fall programs yet. They're still on the books. We might make that call by August, but that's just going to depend on the national situation along with just the local one, I would think, from our standpoint.
Absolutely.
So yeah, that's a really good question, George. And I see George is asking me questions now instead of you, Dave, because I whined about it last week. Yeah, George, every question you type in about 30 questions, and they were all to Dave. And I said, "What am I, chopped liver?" And now he's ignoring Dave. Next up, Rick. I'm surprised you're not in on this too. I think we should ask some questions of Rick as well.
I take them as they come.
There you go. All right. Yeah, George needs a road trip and a golf game. All right, George, I'm all over that. Where are you coming from, George? And what's your handicap? Answer the second question first, because as they say, the best golf partner is a guy who's just a little bit worse than you are.
I'd be everybody's buddy.
Perfect golf partner for you, John.
Yeah.
No, I know how to play golf with the boss. So no, I'd be a good golf partner for you. Yeah. So George is an 8. That's about what I am. Although right now I'm at 8.5, but I'm trending upwards. Yeah, I'll be in double digits before too long, I'm pretty sure. Then we'll start playing for money, George. There you go. Well, all righty. Well, the questions have slowed down a little. So in that respect, I'm going to give everybody one last chance for any questions for the four of us. Any questions for John Messenbrink at Mechanical Hub? Any last minute parting shots? Now's your chance to get them in here, folks. We do appreciate again the gift of your time for yet another Wednesday evening, and we're looking forward to next week. This was kind of one of those tweener weeks, right? We're in the middle of Friday is the holiday, right? Because 4th of July is Saturday. I know my wife has Friday off. What's our day off? Is our day off Friday? I can't remember.
Falls on a Saturday.
Yeah. So, but hopes everybody has a wonderful 4th of July. And thank you, Gary, for enjoying summer school. It's been a lot of fun. And if there's no further ado, Ben, any last words you'd like to share with the gang?
Just thank you to everybody, and thank you to you guys for running this awesome program. This is just unbelievable, and I'm learning a little bit more every week, and brushing up and trying to dust off. And you guys are outstanding. Thank you for everything you do, and thank you to everybody who's been part of these for the last couple months, and hopefully we can keep them going.
All right. Thank you.
All right.
Well, thank you, Ben. Thank you, Dave.
Thanks, buddy.
Thank you, Rick.
Glad to be part of it.
Thank you, John.
Hi, John boy.
All righty. And thank you, everybody out there in webinar land. Thanks a lot. Have a happy and safe 4th of July. And we will see you next Wednesday night.
7 o'clock.
Take Go After Dark Summer School. Be good, everybody.
See y'all.
See y'all.